Hi everyone, so let's see the last video of our EM wave, that will be assignment 4. So a very easy assignment it would be, because we have seen a lot of problems in the lecture series itself. So if you are someone who is watching this playlist just for the sake of problems, if you are someone who just needs the problems, so I would recommend to watch the concept video as well. You can skip the conceptual part, but there will be a lot of problems that you can solve. Okay, so certainly if you are just watching it for the conceptual problems only, then you should see the concept video as well. And if you are following it completely right from the beginning, then it is just a new video for you. So you need to solve this assignment. For most of the problems I have written down the answer only. So this is the first one you can solve. This is the second one. You can pause the video and try solving it. Write down your answer. When we solve, you can check your answer. Third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. These 11 questions are there. Very easy problems, because most of the conceptual questions or the tougher part we have already seen in our which videos? In conceptual videos. Okay. So yeah, let's start with the first one. Very easy problem. What is given? Oblique incidence problem it is. Where wave is propagating, if I see the k vector, I can see it is 3ax cap plus under root 3az cap. Okay. And the boundary plane is z equals to 0. Boundary is z equals to 0. So how will I make the diagram? I will make xz plane. I will make xz plane, and z should be horizontal, because boundary is z equals to 0. So this is how we make the diagram. Right? This is your z, this is your x. And how wave is coming? Plus ax and plus az. So this is how the wave is coming. So wave is coming in this manner. Wave is coming in this manner. And which is your incident angle? This is your incident angle. So in z direction you are having 3 x. Okay, in z direction you are having under root 3. In z direction you are having under root 3, and in x direction you are having 3. In x direction you are having 3. Okay, so what will be this angle? This is theta I only. If this is theta I, this is also theta I. So theta I is equals to tan inverse 3 by under root 3. So that is 60 degree. So theta I is equals to 60 degree. Now it will be transmitted. So what we need to find? We need to find transmission angle. So for transmission angle, what you need to do? You can apply our which equation? Snell's law you can apply. So what Snell's law will say? Under root epsilon r1, which is 1 only because this is air. So under root epsilon r1 into sin theta I is equals to under root epsilon r2, which is under root 3 is equals to under root 3 sin theta t. So you need to find sin theta t. What is sin 60? Sin 60 is under root 3 by 2. That is equals to under root 3. So sin theta t is equals to 1 by 2, which is 30 degree. So 30 degree is the answer. Very easy problem. Like if you are not able to solve this problem, then you certainly need to study all the concept right from the beginning, because this is a very basic problem, a very straightforward problem. Most of the students will be able to solve if they have studied this topic. Okay. Let's see this one. In a certain lossy medium, EM wave travels a distance of 10 meter when its amplitude decay 1 by e times of its initial value. So how the amplitude would decay? If you remember how amplitude decays, e naught e to the power minus alpha z. In this manner it decays. So it has decayed to 1 by e times. That means what it shows? The 10 meter is your skin depth, right? 10 meter is my skin depth. So from there, what did you understand? That my alpha value is 1 by 10. Did you understand this point? My alpha value is 1 by 10. And what will be your beta value? So beta value is the phase shift per unit wavelength. Phase shift should be 2 pi per unit wavelength, that is known as beta. So now the phase shift is 45 degree, that means pi by 4. If you walk for how much distance? 10 meter distance. So if you are walking for 10 meter distance, then your phase shift is pi by 4. So what is the value of beta? Pi by 40. Okay, radian per meter. So what will be your gamma? Gamma will be 1 by 10 alpha plus j beta, right? 1 by 10. This will be your gamma. Is that clear to you? Okay, very easy problem. Let's see this one. An EM wave decays to 10% of its initial value, traveling a distance of 3 mm in a lossy medium. Find the distance traveled by the wave where amplitude decays to 20% of its initial value. So very easy problem. It decays to 10% of its initial value. So how it will decay? E is equals to E naught e to the power minus alpha z. So it has decayed to 10%. That means 90% is left, right? If you have traveled for a 3 mm distance, if you have traveled for 3 mm distance, then 90% of electric field is still left. Basically, this is how it will be decaying. This is how it would be decaying. That your amplitude would be decaying in this manner. From E0 to it would be decaying in this manner. So if you have worked for 3 mm, then 10% has been decayed. That means you are being at 0.9 E0. So 0.9 E0. What else they are saying? Find the distance traveled by the wave where amplitude decays 20% of initial value. That means when you are getting 0.8 E0, so what will be the distance? This is what they are asking. So E0 get cancelled. From here I can get the value of alpha. From here I can get the value of alpha. So what will be the value of alpha? Value of alpha will be ln 0.9 divided by 3 mm. ln 0.9 divided by 3 mm. Nipper per millimeter you will get. So let's do the calculation. So where is my gate calculator? 0.9 ln divided by 3 plus minus 0.035 Nipper per millimeter. Okay. So from here what you are getting? 0.8 is equals to e to the power minus alpha value is 0.035, but do not forget it is Nipper per millimeter. Okay. So your answer will also come out to be in millimeter only. Your D will come out to be in millimeter only, because this is Nipper per millimeter. So these kind of things you should take care whenever you solve problems in the examination. So 0.8 ln divided by 0.035. So that is 6.37 we are getting, or 6.35 you can write down. So roughly around 3.65 mm you are getting. So unit was important here. Okay. Okay, let me take a break. I just need to do one work. You can solve this question. This is very easy. You can solve it on your own. Alpha by beta ratio. If you remember the alpha by beta. So I just need to do one work. I will pause the video. Then we will restart. Okay. So let's start this question. So alpha by beta. Do you remember the ratio? How do we write down the alpha by beta ratio? If you remember alpha. What was your alpha? Should I write down all the formula again? Okay. Let me write it down. So alpha omega mu epsilon by 2. Then bracket comes. Then under root 1 plus sigma by omega epsilon whole square and minus 1. This was the complete formula, and divided by beta. So same formula will be there, just there would be plus in between. So mu epsilon by 2 under root 1 plus sigma upon omega epsilon square plus 1. Okay. So what will be your alpha by beta? So for alpha by beta you need to take whole under root. Okay. And here 1 plus, I am assuming x is equals to sigma by omega e, because what we need to find, Loss tangent. So what is your Loss tangent? Loss tangent is equals to x is equals to sigma by omega epsilon. So 1 plus x square minus 1 divided by under root 1 plus x square plus 1. Okay. So alpha by beta value is 1 by 2. So from there what you are getting? Do we have a page? I can add a page. So under root 1 plus x square minus 1, under root 1 plus x square minus 1 divided by under root 1 plus x square plus 1 is equals to what? 1 by 4. So from here what you are getting? Under root 1 plus x square plus 1. So under root 1 plus x square is equals to 5 by 3. So 25 by 9. So x square you are getting 25 by 9 minus 1. That would be 16 by 9. Okay. 16 by 9 you are getting. So our Loss tangent is coming out to be 4 by 3. Very easy question. Just I wanted you to remember that alpha by beta ratio we know. So if you know alpha by beta ratio, then sigma by omega epsilon you can easily get. So that I wanted you to remember. Okay. Let's move to the next one. So this is based on oblique incidence. There is this medium 1, there is medium 2, and then there is medium 3 as well. So first your wave will travel from air to dielectric, then dielectric to air. So what they are saying, you need to calculate the H field strength in air 2. Here you need to calculate. If wave is incident normally with the field strength H equals to 60 ampere by meter. So we do not remember any formula for magnetic field. We remember all the formula for electric field. So what I can write, that my electric field intensity, incident electric field intensity is 60 neta, right? Here this intensity is 60 neta. Now what do I need to find? I need to find the reflection coefficient. So what is the reflection coefficient? Neta 2 minus neta 1 divided by neta 2 plus neta 1. Okay. So what I can do? I can take neta 1, neta 2 as common. So what I will be left with? 1 minus neta 1 by neta 2. Now what do you think what will be neta 1 by neta 2? Neta 1 by neta 2. That would be equals to epsilon r2 divided by epsilon r1. Right? Neta 1 by neta 2 would be equals to epsilon r2 divided by epsilon r1. So under root 4. This would be under root 4 divided by 1 plus under root 4. So that would be minus 1 by 3. 1 minus 2 divided by minus 1 by 3. I hope you know what I am doing. Neta 2 I am taking out. What 1 minus neta 1 by neta 2 upon 1 plus neta 1 by neta 2. And neta is inversely proportional of epsilon. Because what is the formula? This is the formula. So it is inversely proportional of epsilon. Right? So from here I can write down this relation. So neta 1 by neta 2 is equals to epsilon r2 divided by epsilon r1. So epsilon r2 4 by 1. So under root 4 by 1. So 1 minus 2 divided by 1 plus 1 minus 1 by 3. So this is your reflection coefficient. But I am not caring about reflection coefficient. Why so? Because I need transmission coefficient. So do we have a page? Yes, we have a page. So what will be my transmission coefficient? That would be 1 minus 1 by 3. That would be 2 by 3. So my E transmitted would be what? 2 by 3 into 60 neta. 2 by 3 into 60 neta. So that would be 40 neta. Okay, this would be 40 neta. So here you would be having 40 neta. What about from dielectric to air? Now what will happen is that this will go from dielectric to air. So again I need to find transmission and reflection coefficient, right? So what will be my reflection coefficient now? So that will be neta air minus neta dielectric divided by neta air plus neta dielectric. Basically neta 2 minus neta 1 divided by neta 2 plus neta 1. So neta air 2 minus neta dielectric plus divided by neta air 2 plus neta dielectric. Neta 2 minus neta 1 divided by neta 1 plus neta 2. Right? All good? I hope you are understanding what we are doing. From here the wave came, some part got transmitted and some part got reflected back, but we are not caring about reflected back part. We just need to see the transmitted part. So this much part transmitted. Now this part will go in air 2. So how much part will be transmitted to the air 2? That we need to find. Okay. So what is the neta for air? That is 120 pi. And what will be the neta for this guy? That would be divided by under root 4. This will be this and that would be divided by under root 4. So this will be simply 60 only. So minus 60 pi divided by, here plus sign would be coming. So that would be 180 pi. So again it is minus 1 by 3 only. Neta air, something wrong happened here, yeah. Neta 2 was lesser. Neta 2 was 60 here, 60 minus. Yeah, sorry. Here it will be plus, no? Here it will be plus, sorry. So this will be 1 by 3. That's what I was thinking. So this will be 1 by 3. Now what will be the transmission coefficient? That would be 1 plus 1 by 3. That would be 4 by 3. So 40 neta was coming here, 40 neta. This 40 neta was coming here. Now some part will be transmitted. So how much part will be transmitted? 40 neta into 4 by 3. So your electric field in air 2 would be equals to 40 neta into 4 by 3. That would be 160 neta by 3. And if I need to find H air there, so what I need to do? I need to divide by eta only. So what is the answer I will be getting? 163 by eta ampere per meter. Like this eta I was carrying from here, okay. So now it is going into this dielectric. So eta value will not change because I was carrying it from air. From air to dielectric I am going. So this was just my amplitude. If I had written here 60 into 120 pi. So this is just my amplitude. Here I found out the reflection coefficient, then I found out the transmission coefficient. So now my amplitude got changed to 40 neta. So this neta has nothing to do with dielectric. Are you getting this point? I initially took 60 into 120 pi. So now it has become 40 neta. So 40 into 120 pi it has become. Now the transmission coefficient for reflection coefficient from dielectric to air, reflection coefficient from dielectric to air, that has become now 1 by 3. So what will be the transmission? 4 by 3. So 40 neta into 4 by 3. Now this neta again has nothing to do with the dielectric. Why is that so? Because this is just the amplitude we are carrying. So this amplitude we have carried till the last. Now we need to divide by neta. So which neta we will divide? We will divide by neta air. Why neta air? Because we are in the medium 3. We need to find the magnetic field, right? We need to find H field. So we need to divide by eta. Now which eta I will divide with? I will divide by the eta of the medium where I am. So this field is of air. So now I am in the air only. So in the air, if I need to find H, so what I will do? I will divide by eta. So what will be the answer I will be getting? 160 by 3. Is that clear to you? Okay. Let's see this question, a very good question. I don't think anyone was able to solve in the examination when this question came. And to be very honest, when I saw this question, I was also not able to solve. Like, just being honest, there is no doubt in being honest. There is nothing harm in being honest. Like we have solved a lot of questions which have been given wrong in a lot of textbook. So those we have solved. But yeah, just being honest, I was not able to solve this question when it came in front of me for the first time. But now we will solve it. So these kind of questions like becomes very tough because we do not know about complex permeability, complex relative permeability, and complex relative permittivity. We do not discuss it much, and directly when it comes in the examination, it becomes a bit tough. So let's see how we will solve it. Okay. So from air, this is your incident EM wave. So from air to dielectric you are going. So first thing is, certainly there will be some reflection and transmission. So first you need to find reflection and transmission. Just as you change the medium from air to dielectric you are going. So I am not sure how much part will be transmitted. So that I need to check first, that how much part will be transmitted. So for that I need to find reflection coefficient, and for reflection coefficient what do I need? Neta 2 minus neta 1 divided by neta 2 plus neta 1. So neta 1 I already know. Neta 1 is 120 pi. What about neta 2? Your neta 2 is 120 pi under root mu r epsilon r. What do I see here? Mu r and epsilon r are equal. Here mu r is equals to epsilon r is equals to 1 minus j2. So if both are equal, that means what is your neta 2? 120 pi only. Neta 1 and neta 2 both are equal only here, because mu r and epsilon are equal. So what is the transmission coefficient? Sorry, what is the reflection coefficient? Neta 1 and neta 2 are equal, so reflection coefficient is 0. Reflection coefficient is 0. So what is the transmission coefficient? Transmission coefficient will be 1. So all part is transmitted. So a lot of places I have seen the solution, but this step was missing. Which step? That when you change the medium, then certainly you need to check the transmission coefficient as well. Here luckily we got our transmission coefficient to be 1. That means all part is transmitted, but it will not happen always. Although they did not talk about normal incidence or anything like that, but from the diagram we can clearly see that it is a normal incidence, and once we are changing the medium, certainly we need to check the reflection coefficient and transmission coefficient. So that was a very important thing which at lot of places I did not find this step. So that step is important. Luckily here neta 2 and neta 1 was equal. So that's why all part was transmitted and solution goes correct. But this part was important. Now what I need to find? Now electric field will be decaying in dielectric because it is a lossy dielectric. This is a lossy dielectric. There would be some loss. But they did not mention sigma here. So sigma is 0. They did not mention sigma. Sigma is 0. Now sir, sigma is 0. How you are saying this is a lossy dielectric? How I am saying? Because my permeability and my relative permittivity both are complex. What I mean to say is that, what is my gamma? My gamma is under root j omega mu. That's why I asked you to remember this formula. This is my gamma, right? And here sigma is 0. So under root j omega mu j omega epsilon. Now this is under root j square. What will be under root j? What will be j square? J square will be minus 1. So minus omega mu epsilon. Now what you will think? Mu naught mu r, epsilon naught epsilon r. Are you getting this point? Sigma is 0. Sigma is equals to 0. And this is our gamma. Under root j omega mu plus j omega epsilon. So j square will be minus 1 omega square, omega square. Mu and epsilon are left. So what will be mu? Mu will be mu naught mu r, and epsilon will be epsilon naught epsilon r. So what you are going to get? Under root omega square mu naught epsilon naught. And what is your mu r into epsilon r? What is your mu r? Mu r is 1 minus j2. So 1 minus 2j whole square. What I am doing is that mu r into epsilon r is equals to 1 minus 2j into 1 minus 2j. That would be 1 minus 2j whole square. So what I can write? Under root omega square mu naught epsilon naught j into 1 minus 2j. Did you understand this step? What did I do here? 1 minus 2j whole square and under root is there. I just broke down the under root. So what I will be left with? 1 minus 2j. And here what I am left with? Under root minus omega square mu naught epsilon naught. So under root minus 1 is there, no? So that can be taken as j. What is j? J is under root minus 1. Do you agree to this point? Right? Yeah, so what I was saying, this j is under root minus 1 only, no? If you remember the complex number, so complex number concept is built up from here only, that under root minus 1 is written as j. So if you do not support it, then what you can do, from here only you can see that this is under root j omega whole square mu epsilon, right? So you take this j omega whole square outward. So what you will be left with? J omega mu epsilon. Is that clear to you? You can just take this j omega outward. So what you will be getting here? J, this omega square goes outward, so j omega. Then under root mu naught epsilon naught and 1 minus 2j. So let's ignore all these steps, okay? Let's ignore all these steps. I will tell you a simpler step now. So what is the simpler step? The simpler step is j omega square mu epsilon. Okay, so you do not need to worry that what is our j. J is actually under root minus 1 only. If in mathematics you must have studied it, complex number. So that is minus 1 only. So under root minus 1 only, that is j. But now if I take it outward, so what I will be left with? J omega under root mu epsilon. So how mu can be written as? Mu naught mu r epsilon naught epsilon r. Right? So j omega mu naught epsilon naught. And this will be mu r epsilon r. So what is your mu r? That is equals to epsilon r only. That is 1 minus 2j. Right? So if you solve this one, what you are going to get? J omega under root mu naught epsilon naught. If you solve this one, what you will get? 1 minus 2j. Say yes or no? Under root mu r epsilon r. Under root mu r epsilon r. That would be under root 1 minus 2j whole square. That would be equals to 1 minus 2j only. So this is what I am getting. And if I solve from here, what I will get? So that will be 2 omega mu naught epsilon naught plus j omega under root mu naught epsilon naught. And gamma can be written as alpha plus j beta. So even if your sigma is 0, even if conductivity is 0, but my permittivity and permeability are complex, because of that I am having some alpha, and alpha is coming out to be 2 omega under root mu naught epsilon naught. Did you get this point? A very important point, that even if sigma was 0, even if my sigma was 0, still it was a lossy medium. Why it was a lossy medium? Because your relative permittivity and relative permeability were complex. So you did this analysis, you just went from the basics, that j omega I can take outward, then mu naught mu r epsilon r, then this will be under root mu naught epsilon naught, j omega under root mu naught epsilon naught, this will be under root mu r epsilon r, that would be 1 minus 2j. So from here I took part the real part and I took the imaginary part. How did I take the imaginary part? This is the imaginary part only. If I multiply with 1, and if I multiply with minus 2j, then that will be the imaginary part. So that will be the real part. So which one will be the real part? If you multiply with minus 2j. So what you are going to get? 2 omega under root mu naught epsilon naught. And if you take about the imaginary part, so that will be plus j omega under root mu naught epsilon naught. So this will be your alpha. So what you are getting? 2 into 2 pi into 1.1 gigahertz divided by 3 into 10 to the power 8. Right? Because 1.1 gigahertz was there. So what is the value of alpha we are getting? So here we have solved it. So this we are getting is 46.07 Nipper per meter. So I hope you must have understood this analysis. The alpha value is finite. That means certainly there is some attenuation. So alpha value is finite. Okay. Now what they are saying? Complete part is transmitted. That means from here 10 volt per meter was coming. From here 10 volt per meter was coming. So complete part is transmitted. So here as well at this boundary also there will be 10 volt per meter. Now this 10 volt per meter will be decayed because of this alpha. So how it will be decayed? Your electric field will be 10 volt per meter will be decayed because of this alpha, right? And how much distance it needs to travel? That is 10 centimeter. And what is 10 centimeter? 10 centimeter is 10 into 10 to the power minus 2, which is 0.1 meter, right? So it needs to travel 0.1 meter. So 10 into the power minus 46.07 into 0.1 meter. So 46.07 into 0.1 plus minus e to the power into 10. So we are getting 0.1. So 0.1. So my electric field is 0.1 volt per meter. So this is the answer. Are you understanding what we do? Here the important point we understood that if permittivity and permeability are given complex, then you do not need to think that your medium, and if sigma is 0, then you do not need to think that your medium will be lossless. Still your medium can be lossy because of the complex permittivity and permeability. Now because of that, why it would be complex? Because gamma is coming complex. If gamma was only real, okay, sorry, if gamma was only real, that means there will be only attenuation. But gamma is real plus imaginary. So imaginary part is beta, that is the phase constant. We are not talking about phase constant here. We are talking about the attenuation constant. So here we are getting that there is some real part. So that real part is the attenuation. How did we get? By doing this analysis, that we can take j omega outward under root mu epsilon, mu naught, mu r, epsilon naught, epsilon r. So this we took outward, and this is how we are doing real part and imaginary part. So from there we got the real part, that is 2 omega under root mu naught epsilon naught. From there we are getting the value of alpha. So if we are getting the value of alpha, then we can see the electric field is decaying. So how it is decaying, that we can see, and z is 0.1 meter only. So 0.1 meter distance we need to travel. I don't think anyone was able to solve it during the examination, and I don't think anyone was able to give the correct answer as well at that time. I'm not sure what was happening, because at that time I was not there, I was not an aspirant of GATE. But certainly I don't think anyone was able to give the answer, because this analysis is not that straightforward. Like, it won't click to you very easily that I should start from here. But if someone writes down this step and asks you to solve from here, then you will be able to solve. But this step, how it will click in the examination? So that is a good task, right? So if it had clicked to someone, then it is good. Otherwise, it is very tough to click, right? Let's see this question. What we need to find? The wave is incident on a dielectric medium as shown in the figure, and there is no reflected wave. Since there is no reflected wave, what did you understand by this statement? No reflected wave. That means incident angle is equals to Brewster angle, right? Incident angle is equals to Brewster angle. So this is what we understand. So what is your incident angle? Can you write it down? Certainly I can write down. Where I am going? Plus x and plus z. So plus x and plus z. So that's why this is the wave, right? So plus x and plus z. So plus x and plus z. So in the z you are having under root 2, and in the x you are having 1. This is the angle. So this is your theta I. This is your theta I. So your theta I is tan inverse under root 2. That means theta is equals to theta b parallel. This is parallel polarization. Why this is parallel polarization? You can see here what is the direction of electric field. Electric field is in plus x and minus z. So this is your electric field. I hope you are able to write down these electric fields. So I can see this is my incident electric field. So this is in the plane of incidence only. So certainly it is parallel polarization. Parallel polarization. So this is your parallel polarization, and from here what we are getting is that your tan theta b parallel is equals to under root 2, and that is equals to under root epsilon r2 divided by under root epsilon r1. If you remember the formula, what was the formula of sine square theta b parallel? How did I ask you to remember? Parallel, I can easily make q. Sorry, from parallel I can easily make mu. So it will start from mu. 1 minus mu 2 by mu 1 into epsilon 1 by epsilon 2, and whatever that I have written, that will come downward. Epsilon 1 by epsilon 2 whole square. So this is how I asked you to remember. So this we are not going to write down here, but there is special condition. What is the special condition? That relative permeability is given 1. But this is an old question. Now if they are going to frame these kind of question now, the level of examination has gone up, right? So they will frame the question based on this formula, that is sine square theta b parallel, because they would want you to take mu in action as well. This is what I feel, because now like everyone remembers this formula, they also know this thing, but it is tough to remember this one. But I have given you the trick, parallel mu, so it will start from mu. So 1 minus mu 2 by mu 1, then 2 has come here, so epsilon 1 by epsilon 2, 1 minus epsilon 1 by epsilon 2, whatever that you write here, same will be copied here. So these tricks we have already discussed, how to remember these formulas. So this is how we will remember this formula. Is that clear to you? Okay. So from here epsilon r1 is 1. So from here what is the value of epsilon r2 you are getting? That is 2. A very easy question, a very straightforward problem. Just you need to find the incident angle. Incident angle was coming under root 2, and you also need to check whether it is parallel polarization or perpendicular polarization. So I asked you, I told you one thing, that in case of perpendicular polarization, they will never ask you about the Brewster angle. In case of perpendicular polarization, they will never ask you about the Brewster angle, and the region also we discussed. So there is 99.99% chance is there that if they are asking about Brewster angle, then that certainly it will be parallel polarization, and that also we can see here. So just we applied the formula that my tan theta b parallel is equals to under root 2, which is equals to under root epsilon r2 divided by under root epsilon r1. So epsilon r2 is equals to 2. That is the answer. Let's go to the next one. For an EM wave, you need to find the lowest tangent. A very good question. Think about it. These kind of things we have solved. So how will I write down my E field? How will I write down my E field? So it will have some magnitude. This guy will have some magnitude. What that magnitude will be? That magnitude will be equals to 1 by under root 3 whole square plus 1 whole square. Right? J is just a phase. I told you J is just a phase. You just need to take minus 1 in option. You just need to take minus 1 in action. So minus 1 whole square you write or 1 whole square you write. There is nothing wrong about that. Right? So under root 1 by 3, this guy we will take E naught e to the power minus alpha z cos omega t minus beta z. Now how much phase shift this will provide? What I am talking about, 1 by under root 3 minus j. How much phase shift this will provide? That will provide minus tan inverse 1 by under root 3. That is 30 degree. So this is 30 degree. Ex cap. Okay. So phase shift, what will be the phase shift? Minus 1 by under root 3. Basically, this is in the fourth quadrant. So this you should have the habit that this is your y1 and 1 by under root 3. So, also really sorry, 1 upon 1 by under root 3 it would be, 1 upon 1 by under root 3. So that is 60 degree. Really sorry, this will be 60 degree. Okay. What we are doing in x 1 by under root 3 and in y 1. So what will be the angle? 1 upon 1 by under root 3. But since it is in fourth quadrant, so negative sign will also come. So minus tan inverse under root 3. So that would be minus 60 degree. So these kind of basic things we have already studied. How to write down these angles and all. Now let's see this one. What about the magnitude? Magnitude will be 1 plus under root 3 whole square E naught e to the power minus alpha z cos omega t minus beta z. How much phase shift this will provide? How much phase shift this will provide? So that will provide tan inverse under root 3 but minus sign outward. Right? So this is also providing 60 degree phase shift. So this question I did not frame intelligently, right? So this is also providing 60 degree phase shift. So I did an error in framing this problem. Why is that so? Because now the phase shift between E and H is 0. Phase shift between E and H is 0. That means it has to be lossless medium, no? Why this question went wrong? What is the reason? What is the phase shift between E and H? 0 degree. And phase shift between E and H is 0 degree. That means it has to be lossless medium. But here I am saying there is alpha, right? So some changes I need to do. Okay, it's fine now. Okay, so what will be the phase shift here now? That will be minus 30 degree only, because minus 1 by under root 3 tan theta. So what that would be? Minus 30 degree. So this phase shift will be minus 30 degree. And now what about this guy? And this magnitude will also change. Whatever the magnitude you get, under root 3 whole square plus 1. Okay, and now what about this phase shift? This phase shift will be minus 60 degree only, because here we do not do anything change. So now E is leading H by how much angle? E is leading H by how much angle? It will always lead by theta neta angle. It will always lead by theta neta angle. E will lead H by theta neta angle. This we have already seen. So how much angle it is leading? 30 degree. This is minus 30. It is having some phase of theta minus 30, and it is having some phase of theta minus 60. So this is leading by 30 degree, no? Because theta minus 30 is equals to theta minus 60. So this is ahead by 30 degree. So theta neta is 30 degree. Theta neta is 30 degree. Okay. And what is your theta then? What will be your theta? That would be 2 theta neta. That would be 60 degree. And what you need to find? Loss tangent. Loss tangent is tan theta. That means that is tan 60. And tan 60 is 0, 1 by under root 3, 1 under root 3. So this is your Loss tangent. That is the answer. Did you understand what we did here? Previously, why the question was wrong? Because there was no phase shift. There was no phase shift between E and H. But here we go to know that there is certainly a phase shift. What is that phase shift? And instead of E naught, I should have written H naught here. That is also a mistake. H naught. Okay. So what we need to find? We need to find Loss tangent. For Loss tangent, what do I need? Tan theta. So for tan theta, I need theta value. Theta I can get from 2 theta neta. So how will I get theta neta? For theta neta, what I am gonna do? I am gonna take the phase difference between E and H. So phase difference between E and H is theta neta, right? Because H will always lag behind from E by theta neta angle. So what is theta neta here? What is the phase difference? 30 degree. E is leading by 30 degree. So theta neta is 30 degree. So theta is 60 degree. From there I got the Loss tangent. Okay, a very good question. These kind of questions can be asked in the examination. Let's see this one. Phasor representation, you need to find maximum electric field. These kind of questions also we have solved a lot of times, right? So what is the magnitude of magnetic field? What is the magnitude of magnetic field? That is under root 4 plus 25. And from this one, what you will get? Into under root 16 plus 4. So this is the magnitude. Under root 20 into under root 29 into under root 20. Did you understand this? From here, what you are going to get? Under root 2 square plus 5 square. That would be 25 plus 4, 29. Under root 29. And from here, what you are going to get? 16 plus 4. That would be under root 20. So this is your H naught. What will be your E naught then? Into eta. That's it. So what that would be? 29 into 20 to 20, and then take under root 24.08. So 24.08 neta. 24.08. This value is 24.08 into neta. That's it. A very easy problem. Just you need to take the amplitude. So I have already, we have taken in the theory only, we have taken 20 plus example of such kind, right? More than 20 example we have taken. That how to write the phase, why it is a phase, why we will not take J in action, what is the reason behind that, and how do we write down the time domain form of this. So all these we have seen when we were studying time average pointing vector and when we studied the EM wave propagation in arbitrary direction or general direction. So there we studied all these concepts. Is that clear to you? Right? Let's see this question. What we need to find? An EM wave is propagating in free space is incident on a perfect conducting plate. Not place, it would be plate at x greater than 0. So that doesn't matter, x greater than 0 or what. So this is our boundary which is x equals to 0. So this is our perfect conducting plate. This is your conductor. Okay. Certainly it is your oblique incidence. So let's make it more clear. How will I make the diagram? Although here in this question diagram is not required, but it is a good practice. So here I will keep x, and what is the direction of propagation? X, y. So here I will keep y. So plus x and plus y. So this will be the incident wave. This will be the incident wave. And all part will be transmitted. All part will be reflected. Why is that so? Because this is conductor. What is this? This is conductor. And in conductor, it will not be remaining there. So all part will be transmitted. Sorry, all part will be reflected. Why I am saying transmitted? All part will be reflected. Is that clear to you? What they are asking, let's check. So that the net electric field of the total wave in free space after reflection. What they are asking? Standing wave pattern they are asking basically. This is your incident, this is your reflected. So both combine. This is what they are asking. So what is my incident electric field? This is my incident electric field. What will be your reflected electric field? All part will be transmitted. Basically your gamma will be equals to -1. Gamma will be equals to -1, and it is your perpendicular polarization. This is your perpendicular polarization because this will be your electric field. This is your incident electric field, and this will be your reflected electric field. Because when we study our, what do we study? When we study perpendicular polarization, our assumption is that incident and reflected electric field are in the same direction. But since gamma is becoming negative, that means incident and reflected electric field are in the opposite direction. These kind of things we have already seen in very in-depth manner when we were studying the theory. So certainly it will be in the opposite direction. So this is my EI, this is my ER. So for ER, if I need to write my K vector, so what will change? Changes will happen -x plus y. Initially it was plus x and plus y. Now it is -x and plus y. So x sign will change. Basically this sign will change. So how will I write down my reflected wave? So my ERS would be written as tan e to the power minus j minus x plus y. So x will change. So 6y minus 8x. 6y minus 8x minus az cap. Now what I need to do, I just need to add them up. So I just need to add them up. So E total I need to find. So what that would be? Tan e to the power minus j 6y minus 8x minus az cap plus tan e to the power minus j 6y plus 8x az cap. Okay. So tan e to the power minus j 6y az cap then minus e to the power j 8x plus e to the power minus j 8x, right? What we are taking? We are taking tan into e to the power minus j 6y az cap, that we are taking common. So here what I will be left is minus sign and e to the power j 8x plus e to the power minus j 8x. Is that clear to you? Can I do this thing? Tan into e to the power minus j 6y az cap. Here what you can see is that this thing you can see. Can I divide by 2j and multiply by 2j? Why I am doing so? Because do you know this thing? E to the power iota theta is equals to cos theta plus iota sin theta, and e to the power minus iota theta is equals to cos theta minus iota sin theta. Because cos of minus theta is equals to cos theta only and sin of minus theta is equals to minus sin theta. And if I add both of them, if I subtract both of them, what I am gonna get? E to the power minus theta, e to the power minus e to the power minus j theta minus e to the power minus iota theta. That would come out to be 2 iota sin theta. And from here, sin theta is coming out to be e to the power iota theta minus e to the power minus iota theta divided by 2j. So what this will be equals to? What do you think? This will be equals to 20j is coming here, e to the power minus j by az cap. And what this will be equals to? This will be equals to sin 8x but a negative sign. Is that clear to you or not? So this is my E total. Why negative sign is there? Because this is e to the power j theta minus e to the power minus j theta divided by 2j. This is what they were. This is the formula. But here negative is written beforehand, right? So I need to multiply with minus as well. So from there I am getting this minus sign. Okay, then this will be sin 8x only. Is that clear to you? So this is the answer, right? Now let's see the last question. Very easy question. In which direction wave is propagating? Z, X or Y? What do you think? X or Z? There is no mention of Y. So X or Z? If you have seen the derivation nicely, if you have studied the derivation nicely, then you would be able to tell. This is traveling in Z direction, right? Because my Ex has to be a component of, Ex has to be, Ex will be something like this. Ex cap. That means electric field is dancing in X direction. Electric field is dancing in X direction, but a wave is propagating in Z direction. That's why we are differentiating with respect to space coordinate Z. So space coordinate Z, so it has to be a function of Z only. So wave is propagating in Z direction. It could be plus Z or minus Z, I do not care, but certainly it is traveling in Z direction. That's it about the assignment. That's it about this first chapter, which was our EM wave propagation. Now our EM wave will propagate in a guided medium. Initially it was propagating in free space, right? It was complete free space. It was complete directory. It was conductor. Now in guided medium it will travel. In a guided medium it will travel. Okay. So that we are going to study in transmission line. So I hope you enjoyed this lecture, and those guys who are watching this lecture just for the sake of problems, then I would highly recommend to study from the conceptual part as well, because there we have solved a lot of problems. In assignment I rarely solve more problems because this is your task actually. These 50 minutes I have spent, but this 50 minute it should not take you these 50 minutes to solve this assignment. It should not take 50 minutes because this is your task. You should be able to solve these problems. Just a few things we got to learn. Just this question was good. If you are not able to solve this one, then it was fine. Rest all the problems you should have been able to solve, right? Because we have built up enough concept, right? Yeah. So that's it. Let's meet in the next video where we will start studying transmission line. So from 5th December onwards, we will start a transmission line, most probably from 5th or 6th December. Okay. Thank you very much.